Good morning, everybody, and welcome to this new session of the SUSTAGRI Summer School. Our speaker today is Iban Latasa, which is the head of MULA. MULA is an autonomous electric tractor for multi-purpose agricultural automation, and he's going to talk about autonomous navigation in agriculture, challenges, opportunities, and real-world deployment. So, Ivan, whenever you are ready, you can start.
Thank you. And well, good morning or wherever you are. Afternoon, I don't know where is all the people. I will start a presentation. One moment. Okay. It's okay? Yes.
Yes.
Okay. As you say, what is MULA? It is a multi-purpose electric and autonomous a fruit tractor. This is implemented for permanent crop, and it's an electric tractor, but it's a normal tractor. You can connect any implement that there are in any farm, but also we have developed some specific implements because there are not so many electrical tractors, and most of the implements are developed for diesel tractors. So first of all, we will see a little video for why we develop MULA and what is MULA. So we have seen a short video from MULA that they are blueberries, I think, and this is developed from the first use case to make any work in the farm of a blueberry farm. So we have tested with a lot of implements that you could see here with a brush cutter. Also, it has a weight, and you can transport and weight all the results, and you can monitorize in anywhere how many kilos has the MULA inside them. Also, we have tests for sheet applications, not only outdoor, in a greenhouse also, and another implement with a sprayer. It is going autonomously. Also, supporting any but for everywhere in the farm. So therefore, these are standard implements that farmers could have in his farm, and we can connect them to the MULA.
Ivan, we are experimenting some troubles with the sound.
Yeah, it has finished the sound, I think.
Okay.
Yes, you can hear me now?
Yeah,
Yes.
perfect.
So as I told before, you can connect any implement that any farmer has. There are a little implement. No, it's not for bigger tractors, but then we will see the dimensions of the MULA and the power. And we have also developed a harvester that you will see in the first video, and also now, yeah, because MULA is electric and most of the harvesters are working with diesel. No, so we have developed a specific implement for MULA. Also, we have developed, or we are developing, an ultra and UV lamps for. Well, I'm not agriculture; I'm engineer. So for most of to eliminate the chemical parts and use the UV lamps to kill most of the I don't remember the name of in well to just I don't remember.
You mean
So
weeds or pathogens or?
yes, pathogens. Yes, that's good. Sorry. So now we have here some dimensions of some characteristics of MULA. It can go up to 35%. This I have to stop, but I cannot stop. It can work with 55% inclination. It has the width is 3 meters long and 1.5 more or less of height, and 1.25 of width. This is a dynamic presentation, sorry. Also, it can load more than 1 ton and has a normal implement to connect them. That are the vehicle characteristics. But we also have developed a monitoring system and an autonomous navigation system. We are showing here to manage from any device. We can manage lot of mulas in some farm, not only one farm. You can have more than one farm. Each user has his farms, his mulas, and you can connect them and send a mission. You can select the farm, then you will monitor what is the mula doing in real time. And also you can manage his next mission to go to doing any work in the farm. So you can select one sector or one row and make any work, any agricultural work. And then the mula will start working autonomously. So we have designed we change. You can design. We have designed and manufactured the vehicle and also the autonomous navigation and also the manage of mulas in some farms. That's the electrical part or the vehicle part, and for present the autonomous navigation I will use a Kahoot. I will make some tests for the audience, and then I will explain the answers to the audience. What are we using in MULA? So if people, I will start. I don't know why is, sorry. Well, I don't know why it doesn't start. Sorry. But I don't start.
Iván, ahí donde pone empezar, ¿no funciona ese
I don't see.
enlace? Ahí justo, donde pone MULA Navigation, un poco más
Es que
a la derecha.
es que I have the screen from Zoom and I don't
Ah,
see the
ok.
button. Sorry. So now you can. There are some people. Yeah, the people can connect. Yes. No, I know that. I don't know if the people. If not,
You
you
can you can with your mobile phone you can scan the
the QR.
QR.
Yes. Now.
Then yeah.
Thank you. I will wait 2 minutes or 1 minute. You can scan this QR or connect to kahoot.it and this is the pin of the game. I don't have prices, but if you are welcome, some of you are being in Pamplona, in Navarra. If you return, you will receive a prize from MULA. I will wait 20 seconds more. Bueno, I will start. The first question, which is the precision of GPS and RTK? Okay. Okay, I will answer. We use in MULA, we use for navigation, we use now just only GPS with vertical connection. You can reach, I think, 3 millimeters if you have a calibrated antenna and well, a expensive equipment, but usually the normal vertical is 3 centimeters precision. There is now a solution about 30 centimeters that you don't need to connect to Arctica server, and you can receive the correction directly from satellite. So this is a good solution if you don't need or if you have more sensors to more accurate navigation. And the usual GPS has 30 meters precision. So for precision agriculture is not enough with only the GPS. So you need to connect the GPS to Arctica server, and then you will you will have a good precision. So the next question. How many GPS do you need for navigation if you don't use any other sensor? So no one, well, I don't, you can navigation with more than 2 GPS. You can navigate with 1 GPS, but if you only have 1 GPS, you don't have the information of the orientation of the vehicle, usually. So usually, if you are working with GPS navigation, you should need 2 GPS. One will give the position of the vehicle, and the other, you have to have a distance from one to the other of more than 30 centimeters or more to positioning, to relative positioning. So you will have the correct orientation of the vehicle, because when you are moving, you will have with only one GPS the correct orientation, but when you are stopped, you don't know which is the orientation of the vehicle. So there is no correct answer. So the classification is the which other sensor is not good for navigation. So one of this one, it's not good for navigation, for autonomous navigation. So the compass is not good because we have a lot of metallic parts, motors, drivers, electronic parts. So you have to isolate very good a compass to have a very good orientation of the vehicle. So it's not useful to use a compass. So you will have to use, as I say in the previous question, another GPS to have the orientation. You can use the encoders of the motors to know or to have a better precision of the movement of the vehicle. If you are going ahead, which is the speed, the correct speed, not only with the GPS. With or inertial sensors, you can know if you are if you are not in flat, because you have we are going up the center of vehicle. The GPS will be in the top of the part, but at the center of the vehicle you have to move with the angle of the vehicle. Or if you are not flat, if you are turned in a, you have to know exactly the data. And the cameras also in permanent crop farms, it's very useful to know which is the center of a row, of a plant row. So it is very helpful to go straight ahead between the plants. So we have a new leader. Which is the most expensive sensor for navigation? Time of flight cameras, 3D of artificial intelligence cameras, LiDAR 3D, or radar. So most of you know LiDAR is very expensive, but or more expensive than the others, but also it needs more computing capacity. So it's not only the LiDAR price, but you need also a microcomputer or something like that, or microprocessor, that will be more expensive. I will explain the others. I have another question with this same answer, so I will explain the others sensors. And for risk obstacle detection for safety purpose, which could be a good sensor? I will explain the other sensor. Time-of-flight cameras is like a normal camera, but it not detects image. It detects distance. So they are good for navigation because you have a 3D image. It's more, usually there will be more expensive than stereo cameras. You have the stereo cameras are two cameras separated by a little 5 centimeters more or less, and with artificial intelligence, you can construct the 3D image of we are seeing with the visualization, and also you can detect some objects, not obstacles, objects. But they are limited, and also the leader, they are limited what they are seeing. If you have some plant or leaves or something like that, they are not obstacles because it's not a problem to pass with the MULA or with the other vehicle with a straight ahead from leaves or something that is no risk. You don't see what is behind of them, but with radar, some obstacles are invisible, but the risk obstacles, they could be behind something, but you can see them. So they are good for risk obstacles. And also for safety, you have to integrate a very robustness electronic part or device, because it hasn't it hasn't to fail. The probability of fail, it will be very, very, very low. And these digital sensors, usually they are programmed by in a microcomputer from all the developers, and could have some errors in the program. So for safety, it's better to use, or we use radar, and we have seen more vehicles with radar. And the last question, the last question could change the leader. It's not for autonomous navigation. It's order these devices from more, these implements for more electric power to less electric power. Because it's very important. It's very important in electric vehicle to manage the energy. Because in diesel, you can start the engine and refuel easily. But in electric vehicles, you have to limit the power and also the energy, how many hours can you work. We have developed in MULA two battery capacities because a big part of the price is the price of the battery, because it's similar than an electric car. The biggest is 64 kilowatts. So, well, anyone has, it's very difficult because you have work. So, a lot of people has worked with with diesel implements or with diesel tractors with implements, and they don't know how much energy needs each implement. So we have tested all the works below in the terrain or in the earth, or is the most energy needs. The cultivator needs about 30 or 40 kilowatts per hour. So with 64 kilowatts per hour battery, you have like 1 hour or something like that, or 1.5 hours. The atomizer sprayer, if you don't use the air, the energy consumption is not very high. But if you are using the atomizer with the air, the consumption takes about in 10 kilowatts or 20 kilowatts per hour. So you don't have 2-3 hours per day or per charge of the battery. The brush cutter or the mower usually could be it is for this vehicle that it's not very wide, 125 centimeters. That mowers are about less than 10 kilowatts per hour, and the transport it consumes very less power. You can go with 2 tons or 3 tons, but the consumption is about 2 or 3 kilowatts only, and it is flat. It's enough. You can work hours and hours or days and days with one charge of the battery. So I think that the leader is the same, and the winner is Roy. So Roya, if you are coming to Pamplona, you will have a present from MULA merchandising. So that's all for me. And if you have any question or something or suggestions, I will answer you.